Number 17, solve 3 tangent squared x plus 2 square root of 3 tangent x minus 3 equals 0 for all values of x. Earlier in the school year, we discovered that you could solve problems that are called quadratic by having, say if this was 3x squared plus 2 square root of 3x minus 3 equals 0, by using a technique called x factoring. We labeled these A, B, and C. And there's also another method. If you just use your formula chart, you can use quadratic formula. I'm sure you've learned this in Algebra 2. This could also solve for x using, once you've labeled A, B, and C, by just plugging into this formula here. And we can get x values. But I'm going to use x method because this one has a slight trick to it. When I want to go to factor, you do A times C on the top, and you place B on the bottom. So in this case, I have A of 3 and a C of negative 3. So when I multiply, I get negative 9. And my B is 2 square roots of 3. Now we're looking for two factors that multiply to be negative 9, but add to be 2 square roots of 3. And here's where this is a little tricky, because the square root of 3. Well, I just want to remind you, a square root of 3 times a square root of 3 is equal to the square root of 9, which is simply 3. So here's what this means. We could have 3 square roots of 3 times the square root of 3. The square root of 3 times square root of 3 will multiply to give you 3, and then multiplying that by another 3 should give us 9. We want this to be negative, but we want this to be positive. I need to subtract this one. This way, 3 square roots of 3 minus the square root of 3 would equal this. So we just discovered that I could factor this. So your A value stays the same. You just break the power as 3x plus 3 square roots of 3 and 3x minus the square root of 3. Now, whenever we factor, if your A is greater than 1, one of these parentheses should simplify, which is here. This one will simplify by being divided by 3. You do not divide inside the square root, so it's just going to look like this. It'll be x plus square root of 3 and 3x minus square root of 3 equals 0. Now, according to the zero product property of algebra, it says if you're multiplying at least two items together and you're getting a product of 0, one of these two must equal 0. It's the only way mathematically to multiply and get 0. So either x plus square root of 3 equals 0, or 3x minus square root of 3 equals 0. To solve this problem, I would subtract the square root of 3, so x equals negative square root of 3. Or here, we'd have 3x equals positive square root of 3, and then I would divide that by 3, and I would come up with that x is equal to square root of 3 over 3. Now let's substitute back. X, this whole problem was supposed to represent tangent. So this means that here, tangent x is equal to negative square root of 3. Or here, we would have that tangent x is equal to square root of 3 over 3. Now I'm going to use my hand trick. So negative square root of 3, that means from the hand trick, that would be like negative square root of 3 over square root 1. So I need to have 3 y fingers and 1 x finger. I'm bending my pointer finger, and I'm doing backwards here because I would have to do an inverse here. So my hand, looking at the back of my hand, I'm bending my pointer finger. Should have 3 on top, 1 on the bottom. I flip it over, and I ask myself, what's the location of that angle? The answer is pi over 3. So this is a pi over 3 value here. And over on this side, this value comes from, again, where does it come from? Well, this 3 is the same thing as square root of 3 times square root 3. And that would mean these would cancel out. And so this is from the value 1 over square root 3 or square root 1 over square root 3. So I'm looking at the back of my hand. This time I want 1 finger on top and 3 on bottom. So when I bend, I'm bending my ring finger, flip it over, ask myself what location is that? That is pi over 6. So my answers come from pi over 3 family or the pi over 6 family. I'll put up a little graph here. I'm going to label this all students take calculus. This answer says we need a negative square root of 3. That means tangent has to be negative. So we're looking, tangent's positive in these two. Positive and positive. Here it's negative and negative. So I'm looking for the pi over 3 that would be in this quadrant. So what's the pi over 3 here? If it's almost 1 whole pi, it is 2 pi over 3. This value, this answer would be 2 pi over 3. Over here, it's almost 2 pi, just a little bit less. So this one would be 5 pi over 3. On the other hand, this value, we're looking for the positive. So the pi over 6 family would be over here. So this is pi over 6. And down here, our value would be 7 pi over 6. It's a little bit more than 1 pi. So these look like the potential 4 different answers. You could plug them in to check them. Or what I'm going to do is I'll go over to the graph and see how many times this would possibly cross. Or actually, you know what? It says solve for all. So when it says all, it includes coterminal. So I'll just write them out. And I'll write with the coterminal symbol. So you'd take the first value, which is here. You'd say this is pi over 6, and you'd put plus k pi. And that would take this value and this value together, because adding k pi would switch you across the origin. And then I need to add this value, which is 2 pi over 3, and add k pi. And this is where k is an integer. And that would be my answer here.